Hi everybody, in this video I'm going to do a few more examples of integration with substitution, and these get a little trickier, so make sure you watch all of the examples so that you can see what to do when things get complicated, especially as you have more factors that you're trying to integrate.
The square root of 7x plus 3 dx. So there's only kind of one thing here. It's the 7x plus 3, so we're going to make that the u. The derivative of that is 7 dx. What you notice is that you don't have a 7, so you divide by it. So 1/7 of du is dx. And we're going to rewrite the original. So before I put in the u's, I'm going to say this was 7x plus 3 to the 1/2 power. Then the 7x plus 3 becomes u. It's to the 1/2 power. dx is equal to 1/7 of du. I integrate. So I'm adding 1. When I add 1 to a half, I get 3/2. I divide by 3/2. I keep the 1/7, and then I say plus c. So be careful with the fractions. Make sure you're paying attention. When I divide by a fraction, I multiply by the reciprocal, so there's a 2/3. U was 7x plus 3. It's to the 3/2 power. I have 1/7 plus c. We can put the two fractions together. They're multiplying. So 2 times 1 is 2. 3 times 7 is 21. I have 7x plus 3 to the 3/2 plus c. This one's a little different because I have x and I have x plus 3 to the power 5. And for the first time, the power inside the parentheses and the power outside the parentheses are equal. These are both power 1. So there is going to be like a little twist to this one. You should be able to say that I know what I'm going to start with. I'm going to start with u is x plus 3, right? It's the one that's to the power. It has parentheses. I know that that's u. I take the derivative. The derivative of x plus 3 is just dx. And here's the real problem with this one. I still have this x outside. So the x plus 3 is u. The dx is du, but I still have this x here. So the trick is if u is equal to x plus 3, I'm going to solve for x, so u minus 3 is going to be x. So I have to solve for this x in terms of u. So now I have parentheses u minus 3, u to the power 5 du. Essentially what I did is I took the power and I made it go to a monomial. So the x plus 3, I can't put the 5 through, but when I have u to the power 5, I can. So now I can distribute. So I have u to the 6 minus 3u to the 5th du. This becomes u to the 7/7 minus 3u to the 6/6 plus c. This is u to the 7/7 minus 1/2 u to the 6 plus c. Remember, u is really x plus 3, so I have x plus 3 to the 7/7 minus 1/2 x plus 3 to the 6 plus c. Here's our last one. I have the integral of 2x cubed times x squared plus 1 to the 7 dx. We're starting with u, and it needs to be the x squared plus 1 because it's raised to the power 7. Then I take the derivative. Du is 2x dx. This one is sort of like the last one in that I have x twice, and this time the power on the outside is bigger than the power on the inside. So I'm just going to kind of break it apart a little bit. So 2x cubed, see how I need this 2x? So I'm going to say, well, this is 2x times x squared. See how that's still x cubed? Then I have x squared plus 1 to the 7th, and I have dx. So the x squared plus 1, this is u. The 2x along with the dx, that's going to be du. I still have this x squared. So I go back to u. U says it's x squared plus 1. So I'm going to make u minus 1 x squared. So that way I can write this x squared term that's left over as u minus 1. How do you know when to do this? It's again about powers. So it's noticing the power outside the parentheses is greater than or equal to the power inside the parentheses, and this is when you do this trick. So let's look at what we have left over. So the 2x with the dx, that's du. Let's write that at the end. The x squared is u minus 1. X squared plus 1 squared, and this is actually power 7 here. This is u to the 7. And what this allows me to do is distribute. So u to the 7th times u is u to the 8th. U to the 7th times 1 is u to the 7th. This is du. Now when I integrate, power goes up. So this is u to the 9 over 9 minus u to the 8 over 8 plus c. U originally, right here, says x squared plus 1. So I have x squared plus 1 to the 9th over 9 minus x squared plus 1 to the 8 over 8 plus c. So hopefully you see from these videos that substitution is just a trick we employ to take something that we can't integrate using the power rule, the rule for e, or the rule for 1 over x, and turn it into something that we can integrate. The best way to get better at integration is to do integration. So do the homework. There's always extra practice you can do, but the more you do it, the better you will get, and you'll be able to decide quickly what is u, what is du, and what do I need to manipulate.